All right, we've got this massive multiple choice with multiple answers. It's going to be fun. There is a continuous function f of x on the closed interval from 1 to 5. Okay, 1 to 5. And I graphed it, plotted a couple points just so we'd have a visual for it. It is known that f of 1 equals -2, good to know, and f of 5 equals 4. So now we have a little better visual, hard to say. Choose every correct statement. We might have 1, 2, 3, 4, 5, or 6 correct statements. So, no, we won't have all 6, I'll tell you that right now. So basically what I'm saying is there's a function and it passes through that point and it passes through that point. So scrap paper very quickly. I do not know what this function looks like. I just know that it's continuous. So this is what the function does not look like. There's a point, there's a point. You can kind of see it bleeding through the paper just a little bit. I know that I don't have this situation going on because the function is continuous. I also know that I don't have this situation going on with an asymptote or an asymptote that goes the other way, or like I know I don't have that. I have a continuous function. So what I know I have, I know I have is a connection between this point and this point. What I don't know is, are these points connected like that? Or are these points connected like that? Or are these points connected, where's red? There you are, red, like that. Or are these, I'm making all kinds of fantastic artwork. I don't know how these points are connected. Maybe it goes way up. Let's switch to purple, having fun here. Draw whatever I want. Maybe it goes way up and way down and has a sharp edge and then, oops, almost, that one, not quite a function, but I have no idea what it looks like. So here goes. The minimum value on that interval is -2. Yeah, no. You might be like, yeah, that's the lowest. Is it now? Let's look at the green one. From here to here, the lowest was there at -2? Not necessarily. This would be an excellent multiple choice question if you only had just one choice, only one option to pick. We have several. This will be an excellent multiple choice question because you don't know what happens in between it. So you have to be careful how you assume things. So you don't know if -2 is the lowest or if you have this situation going on. So don't check that box. The highest value is 4. Okay, well, is it? In this situation, it is. In this situation, it's not. There's a y value of 4 and that goes even higher, so no. There is a value c. Okay, c is usually an x value. There is a value c in the interval from 1 to 5 such that f of c is greater than f of x for all x in the interval from 1 to 5. What? Okay, one of the hard things about this class is the way things are worded. Let's go very carefully and slowly again. There is some x value between 1 and 5, including 1 and 5, such that the y value associated with that is greater than the function for any other x value. Let's reword that one more time. There is some value in between here and here, some x value in between 1 and 5. This is 1, this is 5. There is some x value in between here and here. We're going to call it c. And that c value has an output that's greater than all the other values of the function for all x. And that's true. No matter how I draw this, if I draw it down, I have a c value, it's not this one, it's actually 5, that's greater than all the other ones. Or I could draw it like this, and that kind of does correspond to this, so this sort of corresponds there, not quite, but close. This value, we'll call it that one right there, is higher than all the others, and it corresponds to C if I draw my line crooked. There is one, at least one, value where the y value is greater than all the other y values. It's true. Okay, there's a value c, not necessarily the same c as this one, okay, let's not confuse them, in the interval from 1 to 5 such that f of c is less than f of x for all x in the interval. Well, if I'm going to have the biggest, okay, this is the extreme value theorem right here. If I'm going to have a biggest, I'm going to have a smallest. I'm going to. Right here, the lowest value, right there. So whatever whatever the y value is there, it's lower than all the other ones, and I can have some value associated with it. Maybe it's not that value, but there is some x value associated with it, whereas with that x value, the output is lower than all the others. Or in this x value, the output is higher than all the others. No matter how you draw it, you're going to have at least one x value that has a y value associated that's greater than all the others and one that's less. This is the extreme value theorem in the wordiest way possible. We don't have enough information to say. We do too, because they told me it was continuous. And going back to the very beginning of the notes, all I need is continuity. That's all I need. And we have continuity, not enough information. Nope, don't check those. Okay, now we get to a tricky question that I actually used to not know the answer to myself, and then I realized all I need is continuity. So the answer to this next question is, let's draw it. Does the function y equals 3 satisfy the conditions of the extreme value theorem on the interval from -2 to 5? And we're going to draw y equals 3. I'm going to draw it in red. So the function y equals 3 is there. I'm going to draw it with little closed circles on the end just because we're stopping there. Does this have a high point? You might be tempted to say no, but actually the answer is yes. Does it have a low point? Yes. Okay. If I said, what is the maximum? Actually, every point is the maximum, and every point is the minimum. All I need to satisfy the conditions of the extreme value theorem is continuity. So let's do this. Yes, it does. The function is continuous. You have an infinite number of points from here to here that are the highest and they are the lowest. I know it's wacky, but all we had to have was continuity. Let me go a little further. The function is continuous, and I think continuity on the interval is important. So let's continue the sentence. Continuous, I was about to stop the video. Aren't you glad I didn't? There we go. Continuous on that interval.